This is just a very general lesson regarding ways to find the slope between 2 points. So first of all, what we need to understand is that there are several ways to show 2 different points. One way is using a table. So I can write 2 points as 1, 4, and 3, 7 using a table. I could also just write the 2 points as 1, 4 and 3, 7. Both of those methods represent 2 different points. Of course, I could also create an x and y axis and graph my 2 points 1, 4 and 3, 7. If I did decide to graph the 2 points, I could look at the point on the bottom left, that would be the easiest thing for me to do, and figure out in order to get from 1, 4 to 3, 7, well, I would have to start by moving up or down from 1, 4. So I would have to move up 1, 2, 3 places. So my slope would be positive 3 over. Keep in mind that I'm always going to have moving up or down or my change in y in the numerator. Now I'm going to have to move over. So if I'm at 1 and I want to get over to 3, I'm going to have to go over 2 places to the right. So my slope, which I'm going to abbreviate as m, is just 3 over 2. Even though 3 over 2 is a nice decimal, I'm always going to display my slope as a fraction, unless it's a whole number, just because it's going to make it easier for me to graph. Now, looking at the points in a table, rather than looking at them as a graph, I could certainly look at the change in x and the change in y. For example, I could look at, to get from 4 to 7, well, I would have to go up 3, or I would have to go 3 places. In order to get from 1 to 2, I would have to go plus 2. So again, my change in y over change in x, in this case, is going to be positive 3 over positive 2, or I should just write it as 3 over 2. Now, most students are familiar with a third, more common way to find the slope between 2 points. And keep in mind that all of these methods can be used to find the slope between 2 points, can be used accurately, and I'm sure that there are some additional methods that I haven't covered. But this last method takes the 2 points and we start by labeling them. So I'm going to label 1, 4 as x1, y1. And I'm going to label 3, 2 as x2, y2. And at some point in our math careers, we may have learned the formula that the slope, or m, is equal to y2 minus y1 all over x2 minus x1. Now some people will argue with me and say, wait a minute, I learned it as y1 minus y2 all over x1 minus x2. Well, the fact of the matter is, it really doesn't matter. Either of those forms is perfectly fine. The important part is that the y's and the x's that are above each other should be the x's and y's from the same point. So I need to make sure that, for example, y2 and x2 are indeed from the exact same point, and y1 and x1 in this example are from the same point. So if I were going to use this formula, and just for the sake of argument, I'll use y2 minus y1 over x2 minus x1. So I'm going to plug in 7 minus 4, and that's going to be over 3 minus 1. So just checking this real quick, the 7 and the 3 are on top of each other, and the 7 and the 3 both come from the same point. The 4 and the 1 also are from the same point. So 7 minus 4 is absolutely 3. 3 minus 1 is 2. So I can use any of those methods and still find that the slope between the 2 points is 3 over 2. So let's find the slope between these 2 new points. So I'm going to label my 4 as x1, my 5 as y1, my 3 as x2, my 1 as y2. And I'm going to use the formula, my slope m equals y2 minus y1, 1 minus 5, all over x2 minus x1, 3 minus 4. That's going to give me negative 4 over negative 1. A negative over a negative, I need to remember, is a positive, so in this case I'm going to write my slope as 4, or I could write it as 4 over 1. Either one is equally appropriate. But let's say that I really don't like formulas at all, and I'd rather use the differences looking at the tables. So I'm going to create a table of those 2 points. Oh wow, I put the points in a different order than how I received them. It really doesn't matter. If I'm looking at change in y, from 1 to 5 I'm going to go up 4. From 3 to 4 I'm going to go up 1. That gives me a slope of positive 4 over positive 1, which is absolutely equal to the negative 4 over negative 1. They're both just positive 4.